Okay, we are in section 7 point, or I'm sorry, section 2.7, where we're going to use decimal operations and equations with decimals. So when it comes to adding and subtracting decimals, we need to make sure that the decimal points are lined up, and then we can add and subtract as we normally do. So if we use the example that's given to us here, we can write it out vertically, like saying, okay, I got 25.38. And then in this case here, it's a subtraction, but we're subtracting it by a negative number. So this is where we cross the line, change the sign, which turns into a plus operation. So now I got the plus, and if you notice that the decimal point is right here, so I have to write in the 42, and then I have the 7, 3, and 4 after that. Usually anytime that you have to fill in some spaces, you can fill it in with 0. All right, it's not necessary, but it does kind of help. And then you can just add it as we go along. 0 plus 4 is 4. 8 plus 3 is 11, so I got 1, carry it, 10, and 11, carry it there. We got 7, we got 8, and we have 6. So that's where we get it right here, and we can say that it's going to be 68.114. Okay, so if we go here, this is where we have just a subtraction problem. Again, we'll try to go vertically, and we got 3.425, and it gets subtracted by 3.28, and we can write in the 0 there as well, and then do the subtraction as we do. So we got 5, this turns into 12, this turns into 3, 12 minus 8 is 4, 3 minus 1, 3 minus 2 is 1, and then 3 minus 3 is 0, so we can just write 0 there. So now I got 0.145, like so. When you're multiplying fractions, you don't have to line up the decimals. Once you've had multiplied the two numbers, this says locate where the decimal should be in the product. Your answer by counting the decimal places in the numbers you multiplied together. So, you know, essentially you can go like this. You can just forget about the decimals when you multiply. You could take like, oh, just 1, 6, 1, and then multiply it by 3, 2, 5, and 7. Okay, stuff like that. So if you type that in your calculator, 161 times it by 3257, you would get 524,377. Okay, so now what we have to figure out is where the decimal place is going to go. All right, so if you look here, the decimal place is move 1 unit. So now I just go here and I go 1. Now I go over here and I go 1, 2. So now I do an additional 2 more times. 1, 2. So now my decimal place is placed there. So then my final answer would be 524.377. And you can check that with your calculator as well. And it does come out. When you are dividing decimals, it says set up the division problem by using a division bar. All right, multiply the divisor by a power of 10, which makes it into a whole number. Multiply the dividend by the same number. So whatever you do to one side, you must do to the other side. So in this case here, you write this out. This is your divisor here. This is your dividend. That means that the negative 29.07 goes in the inside of the fraction bar, and the negative 1.9 goes on the outside. So what they really are saying is they want this number to be a whole number. And in order for that to become a whole number, I have to move the decimal place one spot to the right. And since I used it one spot to the right, I must do one spot to the right inside the dividend. So instead of it being um, negative 1.9 on the outside, it's now essentially it could be negative 19. And instead of negative 29.07, it is now negative 290.7. And you get the same answer. All right. Um, I understand that a lot of times students get apprehensive to be able to solve with decimals, especially when in an algebraic equation. Um, the best thing to do if you want to eliminate any kind of decimals in the problem is to, in this case, you could multiply the entire equation by 10. All right, so if you did that, that would mean that instead of subtracting 4.7 to both sides here, I get x equals 3.5 minus 4.7. I get negative 1.2. If you multiplied it out by 10, which means you just take right here and then multiply everything by 10, which then turns into 10x plus 47 equals 35. All right, subtract 47 to both sides. I got 10x equals a negative 12. Divide everything by 10. X is still going to equal the negative 1.2. All right, it's all in how you see it. Both ways are uh, perfectly good ways to solve it. It's all on personal preference. Looking at algebraic equations where you have to incorporate division or multiplication, same thing. Um, in this case here, we have to divide both sides by 7. Those cancel out to be 1. That means x is now going to equal whatever 40.6 divided by 7 is, and that happens to be 5.8. If we look at b in this scenario, for us to get y by itself, I have to multiply 11.5 to both sides. That cancels out to be 1, so that's why I can get y by itself over here. So 0.4 times it by 11.5 gives me 4.6. You will have some questions where you will be given an area of an object. In this case, the object that is given to us in the picture is a rectangle. Um, the general formula for area of a rectangle is length times it by width. We have a unique situation where they give us the area, all right? They're telling us that it is 49.65 square centimeters. They give us one measurement, but they don't give us the other one. All right, this looks like appears to be the longest of the two side lengths, so I'll call that the length. And then this one would be in the smaller one, I'll call this one the width. So what they're asking us here is they want us to find what the length of that rectangle will happen to be. So the best part about it is we are just inserting values into the formula and solving for what we don't know. All right, so what we do know that the area of our rectangle is 49.65. We know that. The length, we don't know what it is, but they tell us that it's a variable x, and they tell us that the width is 3.75. All right, now I like to have my variable on the other side, so I'm just going to rewrite it. Okay, now from here, in order to solve for x, we simply divide both sides by this 3.75. That gets canceled, so now I have x here, and now it's going to be 49.65 divided by 3.75, and that gives us a value of 13.24 centimeters. All right, it's not square centimeters because remember, see the centimeters here, it would be centimeters here. The only time you deal with the square centimeters is when you're looking at the area of your object. Okay, so that is how you find or how you solve operations with decimal points. Hope this helps. Till next time.